Welcome to my presentation on human-computer interaction, with a focus on electronic health records. I'm pleased to have this time to introduce you to this dynamic field. First, I will define what human-computer interaction, or HCI, is and outline its overall goal and general strategies. Then, I will provide a short overview of HCI's history. Then I will outline the present state of HCI and describe some effects of this interactive process. Next, I will draw in information on the specialty area of electronic health records, or EHRs, by providing a definition, goal and strategies. Then, I will outline the present state of EHRs. Finally, I will conclude with a look forward to see where future trends in HCI and EHRs may go. I have three objectives for this presentation: to provide an overview of the concept of HCI including a definition, history and current status report, to present strategies that may increase successful adoption of an EHR, to critically examine how HCI has changed some elements of our personal and professional lives. This definition represents several authors' words, a discipline examining interactions between humans, computers, and the environment that merges several fields of study. This includes cognitive sciences, data mining, information design, graphics and computer systems engineering. This is what Carroll, in 2013 refers to as a community of communities. The overall goal of HCI is to make computer systems usable. More specifically, HCI seeks to minimize the distance between the humans and computers' understanding of the task. This is referred to as reducing the design reality gap. Strategies of HCI can be grouped into human, computer and interactive factors. User needs, rather than computer needs, should be at the center with the user involved in the design process if possible. The user's physical and cognitive abilities, task requirements and environment need to be included in the design. Finally, the user should be able to tailor the system to suit personal needs and be able to learn and work with it without referring to a complex user manual. Computer design is also critical. Interfaces are how users interact with the computer and should minimize fear and frustration. Touch surfaces like the iPhone work well. Good workstation ergonomics need to be employed. Furthermore, interfaces should be simple, adapt to the individual user and anticipate user responses. The interaction itself also needs consideration. Use the simplest design possible to achieve the task, be able to recognize and recover from error. Make use of proven strategies for decreasing the cognitive burden of a task by arranging things logically. Use menus, lists, and alphabetization. The history of HCI, or man-machine interaction as it was originally called, is relatively short. We begin at the University of Pennsylvania with the unveiling of the Electronic Numerical Integrator and Calculator, or ENIAC, in 1946. It is designed to calculate ballistics for the U.S. Army and uses punch cards and transistor tubes. It is 10 feet tall, 1,000 square feet, and uses enough energy for a small town. Fast forward to the late 1970s, this marks the emergence of the desktop computer and keyboard. This theoretically makes personal computing available to everyone. However, arcane system commands limit the use to industry professionals and dedicated hobbyists. Concurrently, there are advances in other fields such as cognitive psychology, artificial intelligence, human factors and documentation. This congruence of fields, coupled with serious usability deficiencies, lead designers to focus on usability and experiment with prototypes and empirical testing. A significant paradigm shift occurs in the early 1980s with the messy desktop design by Apple Macintosh. This marks the first directly manipulable graphic interface. Advances in technology bring a host of changes to the desktop, including laptops, handhelds and smartphones. Users are now able to directly interact with the graphic interface. Other advances including the internet and hyperlink technology make connectivity, and interacting with people through, rather than with computers, singularly important. At present, HCI has grown from generic single users to a diverse range of individuals and group users. Functions have expanded from calculations to encompass almost a full range of human experience, including games, education, commerce, governance, and healthcare. We relate with computers in an increasingly personal manner with devices embedded in our phones, buildings, cars, clothes, and bodies. This brings us to what Rogers in 2009 referred to as the age of ubiquitous computing. Some effects of these technological relationship changes include altered personal boundaries as computers enter or extend our physical, cognitive, professional and social lives, significant change to health, educational, governmental, social and cultural practices, dissolving boundaries between our home, work, and social lives, a tremendous increase in the amount of information available on all aspects of our lives including personal, commercial, health and governmental. Let's focus in on a very important HCI specialty area, the electronic health record, or EHR. McGonigal and Masterian in 2012 define an EHR as a computer-based data warehouse of information that replaces the former paper record. The goal of the EHR is to systematically document the health status and care of a client using a secure digital format, accessible by authorized interdisciplinary professionals to support efficient, high-quality care across the client's healthcare continuum. In other words, to provide the right information, at the right place, to the right person in the right time. There are many strategies associated with successful EHR implementation. In addition to the project team and the technology department, the end user should be involved in all phases of the EHR process including design, development and implementation. Instilling and maintaining a positive attitude is critical. This can be facilitated by making end users aware early of the EHR's benefits and developing a sense of ownership of the end result. User training and support is also critical, so ensure it is well planned, uses a variety of modalities, occurs regularly and has good technical support when needed. The computer system itself should be relatively invisible such that users do not have to cope with technical failures. All of the data systems need to communicate well so data is transferred and updated effectively. This minimizes error and reduces workload. The EHR software should be designed to simplify tasks to help reduce cognitive fatigue and minimize error. All staff, from executives to the front line, need to plan, incorporate and support changes that accompany EHR implementation. Without these accommodations, there is little improvement to productivity. This total change effort is referred to as a socio-technical change project. This is possibly the most important strategy discussed so far. Currently, EHRs are receiving mixed reviews. Many authors note EHR implementations do not go well. Issues include double data entry, poor workflow integration, increased workload, ergonomic injuries and slowed access to information. The anticipated gains in efficiency, storage and costs have not been automatic and depend tremendously on the specific characteristics of the software and implementation process. Currently, 1/3 of users find EHRs very bad and there is only 7% adoption overall in the US. So where do we go from here? Advances in HCI technology appear to be moving towards alternate input methods including facial, body or handwriting recognition, and devices implanted directly into our bodies. Methodologically, HCI is moving towards examining the felt experience for emotive qualities such as fun or annoyance as we relate to our devices. The evolution of the EHR appears to be predicated on achieving standardization of a huge variety of computer systems including hardware, software, and network. Human systems, including terminology, assessments, and documentation practices also need standardization if true interoperability is to be achieved. This is possibly the largest challenge facing the developers and users of EHRs. The current state of HCI and EHR has evolved out of a rich tapestry of theory and technological advancement. This presentation itself is an example of a human-computer interaction. This is not my voice.
This is.
And this is not my image.
This is. Where we go from here depends on us, our understanding not only of technology, but how we will use and be affected by it. How our ethics, our institutions, and even our humanity will be shaped by it. As Carol in 2013 says, we need to construct our future, not just find it.